الآن بدنا نحكي عن example على تاقوشي ميثود. الإكزامبل هذا بدنا نحاول إن نعمله على المينيتاب. تمام، نشغل مينيتاب من ظهور جديد. لاحظوا الإكزامبل عبارة عن إيش؟ اكسبيرمنت من 4 فاكتور. الفاكتور الأول temperature، الضغط pressure، doping amount، deposition rate. Each factor has 3 levels: temperature 100, 150, 200 degrees Celsius, pressure 2 psi, 5 psi, 8 psi pound per square inch, and so on. Now we go to the minitab. From stat DOE taguchi, create taguchi design. The levels, we saw that the levels are 3 level, not mixed. Each factor has 3 levels. Then we select 3 level design. Number of factors, it is 4 factors. There are 4 factors. Design, it is L9, L9, L9. Yes, it is L9. Yes, it is L9. Then so we should select L9. Okay. Factors, here we can name the factors: temperature, pressure, doping rate, deposition, doping amount and deposition rate. Doping amount, deposition rate. The levels, here we can put the values of each factor: 100, 150, 200, 100, space 200. Yes, pressure 2 psi, 4 psi, 8 psi, I think, or 5. It is 5. Space 8258. Yes. Amount 4%, 6%, 8%. 4%, 6%, 8%. Yes. 0.1 milligram per second, 0.2, 0.3, 0.1, 0.2, 0.3 milligram per second, the deposition rate. Yes, this in column 1, column 2, column 3, column 4. Options, store design in worksheet. Yes. Okay. Now the 9 trials or runs are here. Temperature minus, 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 so on. Now we should put the response. What is the response? The response here is this table. The minitab designed it here. 1, 2, 3, 4, 1. We should note here that for this experiment, as we saw, this experiment has 3 levels for 4 factors. And then total runs are the total runs are 3 levels to the power 4, yes, which equal to 81 runs. Here we need 81 runs to make the experiment. So taguchi here make very fewer runs, which are 9 runs, as we see from the minitab here. It is L9. Then we can now make the inputs of the response, which are here 3 trials of the yield. 3 trials. Trial 1, trial 2, trial 3, Control C, and here Control V. One column and one column. That is not possible. Now stat UE taguchi, analyze taguchi design. The response are the 3 trials. Oh, select, yes, graph, signal to noise, standard deviation, okay, analysis, signal to noise means, analysis graph, regular, storage, signal to the ratio and means, standard deviation, okay. Response table for signal to noise ratios. Here the rank is the factor 4, the deposition rate is number 1, doping amount number 2, pressure 3, temperature 4. According to the nominal is the best, 10 log for the best 10, y bar square divided by s square. Install for means. Mean here is the maximum, number 2, number 3, number 4. Main effects plot for the signal to noise. Here the maximum signal to noise is at 0.2, here at 4%, for 8. So the optimum is temperature 200, pressure 8 psi, doping amount 4%, deposition rate 0.2 milligram per second. From here, doping amount is ranked 1, rank 2 is temperature, 3 pressure, and 4 deposition rate. The deposition rate is the 4. As we see here, the signal to noise ratio for run 1, it is 19.47. Standard deviation is here the mean is 8. So if we want to compute this number, we should here signal to noise ratio 1 equal 10 log mean, which is here 80.1, standard deviation 8.5159, square. Yes, here calculator, look 80.1 square 8.5159 square 1.9 multiplied by 10, which is 19.468, which is here 19.468. This is the mean 80.1, and this the standard deviation for this trial. These trials here, the mean equals this plus this plus this divided by 3. 0.3 plus 82.3 plus 70.7 equal divided by 3 or 80.1. Yes, for the standard deviation, this minus this square, and this minus this square, and minus this square root for them, multiply divided by n minus 1, 3 minus 1 minus 2 and so on. We can compute all signal to noise ratio. If we look to this column, we should find that this is the maximum. It is the maximum signal to noise ratio. What it is the experiment here? No, here 89. Yes. The temperature is 150. Temperature is 150. The pressure 8 psi. The doping amount 4%. Deposition rate 0.2. From here we can signal to noise ratio 4.2. What's the problem here? The average signal to noise ratio for the 100 temperature is the average of the 3 signal to noise ratios here. 19.46, yes, 8 plus 21.4568 plus 90.0 0.697 divided by 3, it is the average 19.99. 20 here, it is 20. For the 150, yes, we should take these 3. It should here 20.5. For 200, it is the maximum. It is 22, 24, 20. It is equal 22 point factor. Yes, so the maximum or the optimum temperature is 200. We can repeat the mean signal to noise ratio for each pressure. 2, yes, here 2, 2, 2. For the 2, we should take 90. This 2 is here, yes, 90.46 4.47 plus 270.6 plus 22.25 divided by 3, here 19.77, here 19.7. If we need for deposition rate 0.2, yes, I need 0.2 here. 1 plus 1 plus 1, this divided by 3. From here we can take a conclusion of the optimum experiment, which each one maximum signal to noise ratio, maximum 208 psi, 4%, and 1.2 milligram per second deposition rate.